Good afternoon, everyone. My name is Professor Ademoke. Basically, we are going to be talking about easy way to solve quadratic equation. Many students still find it difficult despite the fact that we have different formula to solve quadratic equation, which is factorization method, and also we have the completing the square method, and at the same time we have using the almighty formula and the graphic method. But students still find it difficult to use all these formula and analysis to solve quadratic equation. Most especially when they want to solve it with factorization method, a lot of students find it very hard for them to think about what is going to be the factor. Is it minus 2 or minus 3? What am I going to use? Is it minus 3 or minus? Some people find to get a mistake by using the sign, maybe positive sign and the negative sign. It's very hard for them to at the same time. Basically, you guys are going to enjoy it. Trust me, this is the easiest way to solve quadratic equation with easy points and easy terminology. Now, let's look at this formula. It's very new for you, but I believe with this little formula we are going to do. It looks like an almighty formula though, but it's not the almighty formula if you check it very well. So I'm going to be explaining, making some introduction about this formula first, before we go on to solve these three examples here. I believe by the grace of God, by the time we are done with these three examples, you find it very easy. Very, very easy. So this y prime here simply means dy dx, that is differentiation. And we're going to be talking about how to differentiate it. This will make you to know two things. The way you can differentiate, and at the same time for you to understand how to use this formula. Basically, very well. So now, let's take the first example, which is x squared minus x minus 12. X squared minus x minus 12 equals 0. Using this formula, the y prime there representing differentiating this value. We differentiate from this side to this side. Now, when we are differentiating from here to here. We are moving like this direction. And differentiating in this side, y over the x, that is what this y prime represents, the y over the x. So basically, it's going to form, if you differentiate x squared, you are going to get 2x, right? 2x. And if you differentiate x, you are going to get what? 1. Because anything raised to power 0 is going to give you 1. So now, many students still find it very hard for them to differentiate. Let me just touch the differentiation a little bit before I go further. So for example, now we are differentiating x squared. In differentiating x squared, you multiply here with 2, this raised to power here, which you are going to get 2x. You then subtract 1 from the power, which is 2 minus 1. You are going to have 2x. 2 minus 1 will give you what? 1. So you are going to have 2x. That's how to differentiate. That's how to differentiate this first value. And in differentiating any x in this form, this is the same thing as raised to power 1. When you multiply a, you are going to get 1x. Then that one minus 1. You are going to have 1x raised to power 0. And you are going to have 1 times 1. X raised to power 0 is 1. So you are going to have 1 times 1, which is going to give you what? 1. So that is the value for that. And when you are differentiating a constant, is what? Automatically is 0. So we are not going to do that. So with the logic of using the formula now, we have to write the differentiation of this point, which is going to be 2x minus 1 to be equals to 10 plus or minus 10 the square root. The b here, that is the second coefficient of this s. And what is the coefficient of s here? Is minus 1. So we have minus 1 everything raised to power 2 minus 4. That is here 4 times our a, which is the leading coefficient. And the leading coefficient here is what? 1. So you put 1 here times our c, which is the constant, which is what? Minus 12. Minus 12. So this is how this is being done. Then you go further by saying 2x minus 1 to be equals to plus or minus. So minus 1 raised to the power 2 is going to give you what? 1. And this place, there's a minus here. 4 times 1, 4. 4 times 12, you are going to get 12 in 4. 4 times 2, 8. 4 times 1, you get 4. That is 48. Minus times minus will give you what? Plus. So I'm going to have plus 48 here. So that's how we get to that point. Then we lead by going further, saying 2x minus 1 to be equals to plus or minus square root. 1 plus 48 will give you what? 49. And the square root of 49 is what? 7. So we then say that 2x minus 1 to be equals to plus or minus 7. Then we move this value to this other side by having 2x to be equals to this minus 1 moving to this side. We thought it was plus 1, which are going to have 1 plus minus 7. Then basically from this place, this one represents, anytime you see a value, something like the plus and minus, representing z, that's going to be 1 plus 7 and 1 or 1 minus 7. You know, in quadratic expression, we have two factors. So now, basically, we are going to do them in different dimensions by dividing both sides by the coefficient of s here, which is 2, by saying that s will be equals to 1 plus, we use plus first, plus 7 all over 2, which is this 2, we are dividing both sides by the coefficient of this x here, or we said 1 minus 7 all over what? 2 again. So from this point, we can then say that 1 plus 7 will give you what? 8. 8 divided by 2 will give you what? 4. So our s is equal to 4, or s is equal to, the second value is 1 minus 7 will give you what? Minus 6. And minus 6 divided by 2 will give you what? Minus 3. So we are going to have minus 3. So these are the factors of this quadratic equation. That is, our s is going to be 4, or s is equal to what? Minus 3. So that is how to use this simple, easy way to solve quadratic equation. The reason for this is that many students find it hard for them to be able to identify this factor easily by the time they want to use factorization method. So I think when you use this logic, it will make you to go to your paved way easily. And we have more two examples to solve before we end the class. So now let's quickly rush about it and solve the next one. Now the next one is s squared plus 5x plus 6 equals to 0. Remember, we are still differentiating. We differentiate from this side to this side. And when we differentiate x raised to the power 2, we are going to get what? 2x. And when we differentiate 5x, we are going to get what? 5. We have 2x plus 5 equals to plus or minus the square root of b squared. And our b, the second coefficient, is 5. So we have 5 raised to the power 2 minus 4 times our a, which is the leading coefficient, is 1 times our constant is 6, which is 6 here. Then we said that 2x plus 5 equals to plus or minus, then square root of 5 raised to the power 2 is 25 minus 4 times 1 4. 4 times 6 is going to give us 24. 4 times 6 is going to give us 24. So we have 24 here applicable. Now we then move forward by saying 2x plus 5 to be equals to plus or minus the square root of this. 25 minus 24 will give you 1. So we have 1 here. Then the square root of 1 is the same thing as 1, amicable. So we have 2x plus 5 to be equals to plus or minus 1. Then you move this one to this side by saying that 2x to be equals to, when this plus 5 comes to this side, it's going to change to what? Minus 5. You have minus 5 plus or minus 1. Then you divide both sides by the coefficient of x by saying x to be equals to minus 5. We are going with plus the up plus this plus that is here first. Minus 5 plus 1 all over 2, or then we move to the next one. Minus 5 minus 1, which is the minus here we are using, all over 2 at the same time. Then from this point, minus 5 plus 1 is going to give us minus 4. So we have x to be equals to minus 4 all over 2. Or, and this one is minus 5 minus 1, which is going to give you minus 6. Which is going to be minus 6 all over 2. Then x is equal to minus 4 divided by 2 is going to give you minus 2. Or x will be equals to this one, 2 divided by 6 is going to give you minus 3 at the same time. It's going to give us minus 3. So that is the value for that. So definitely our x is equal to minus 2 or x is equal to minus 3. So that, now let's talk about the last example. The last example before we end it off.